Today we're going to graph cube root functions very similarly to how we graph square root functions. So what you see in front of you here is the graph of the parent cube root function before we have added any translations or dilations to the function. So this is simply what the cube root of x looks like. So if I step back to the inverse function, which would be the function of x cubed, and dissect where all of our values came from. So if I simply make a t-chart of what our values should be, and I'm going to kind of start in the middle here. Now, unlike the square root function, the cube root function is not going to have any limitations, and we'll observe why here in a moment. So if I plug 0 cubed in, I get 0. If I plug 1 cubed in, I get 1. 2 cubed gives me 8. Negative 1 cubed will give me negative 1. And negative 2 cubed gives me negative 8 when I make a table of values. So I can go ahead and plot these on this graph. You can see it unfold here. So here's 1, 1, negative 1, negative 1. 2 is going to reach all the way up to 8. And negative 2 is going to go down to negative 8. And you can see that my points are just following that red curve. This red curve will be the curve of the original function. So now let's investigate finding the inverse of that function. So just like we have previously done, I'm going to go ahead and flip my x and y variables. And then I'll solve for my y again. So when I solve for y, I will have to take the cube root of both sides. So y is simply going to be the cube root of x. Now, when we had limitations with square root, that was because we could not square root negative values. But you can cube root a negative value because there are values that I can multiply by themselves 3 times and give me a negative value, like negative 2 times negative 2 times negative 2 would give me negative 8. So I can cube root a negative value. Now what does that graph look like? Well, that graph's going to just look like the inverse of this. So basically I can flip my XY t-chart from my previous graph. And when I graph that, this is what I'm going to get. 0, 0 will look as if it did not change. 1, 1, and negative 1, negative 1 looks as if it doesn't change. But then I'll graph 8, positive 2, because that's the cube root, and negative 8, negative 2. So you can see that my graph has now been rotated and is now reflective of that y equals x line. So this gives me the inverse of the cubed function, which is the cube root function. And again, that's the parent graph. So these would be the points of the parent graph's function. So let's look at our translations. Now you're going to see that this looks very familiar to our translations for squared functions, where the k is representing our vertical translations, moving up and down. Our h is going to represent our side to side, and our a is going to represent if we are stretching, if we're compressing, if we are flipping over our axis. That's going to be our orientation and shape. If you need to pause the video and look at those aspects, do so now. Okay, so let's look at our first cube root function. Now remember that I don't have to do that domain check right at the beginning because I am allowed to have negative values. So now I'm going to decide what I want to put in. So I'm going to start my t-chart looking at values that are going to make sense for me. So I still kind of look at what gives me 0 in my radicand, so that it helps me decide where to put points. So if I put a 1 in here, that's going to give me 0. So that kind of gives me a starting point. And what that's going to do is that's going to find that initial inflection point. And we'll talk about that in a minute. So when I put a 1 in here, I get 0 plus 1 is 1. Now that is going to be a special point we'll talk about. So I'm just going to pick a couple points to the left. Let's see if I plug in a 0. So 0 minus 1 is negative 1, and the cube root of negative 1 is negative 1, times 2 is negative 2, plus 1 is negative 1. Now I'm going to go to maybe a number that will give me a perfect cube root. You don't have to. You can go to the next point from here. You can go to negative 1, but I'm going to actually choose negative 7. Because if I put a negative 7 in here, that's going to give me negative 8, and I can cube root negative 8 very easily. The cube root of negative 8 would be negative 2, times 2 is negative 4, plus 1 is negative 3. So that's just making my numbers be clean. They definitely could be decimals, so if you chose to pick negative 1, that is fine also. I'm going to go in the other direction and pick a couple points. So I'm choosing 2 minus 1 is 1, times 2, the cube root of 1 is 1, times 2 plus 1 will give me 3. And then I'm going to pick 9, because again, if I pick 9 minus 1, that will give me 8. And the cube root of 8 is 2 times 2 plus 1 will give me 5. All right, so let's see what we have here when we graph. So I start at 1, 1. I'm going to graph 0, negative 1. Whoops, that's the wrong direction. Actually, right, that's right. So now we go to 2, 3, 1, 2, 3. I'm going to go all the way to 9, so 5, 6, 7, 8, 9 is going to go up to 5, and negative 7 is going to go down to 3. So you can see this elongated curve again, and it's S-shaped. All right, so that point that we picked in the middle that made this 0 is called our point of inflection. That's right here. That's a key component to this. So now let's talk about our other key components, like domain. Now for domain, we have no restrictions. I can see that left to right, I use every value, so my domain will be all real values. My range, and I know it's hard to understand this, but this is going to go gradually down, down, down as I go to the left, and gradually up, up, up as I go to the right. So my range really doesn't have any restrictions either. So my domain and range for this cube root function are both all real values. Now let's look at the end behavior. So the end behavior is what's happening at the ends of our graphs. So as we go to the left of our graph is gradually going to go down. So our function is going to approach negative infinity. As we go to the right of our graph is gradually increasing, moving in a positive infinity direction. So we're able to find the domain, the range, and the end behavior, as well as that point of inflection, which is right in the middle. If I come back to the one that we've seen previously, that point of inflection right here would be at 0, 0 of our parent graph. It's kind of the only point that doesn't have a match to it. So you can see that I can graph 1, 1 and negative 1, negative 1, but 0, 0 doesn't have a pair. It's also where the change in concavity is. So see how the graph is shaped like an upward motion, and then it's shaped like a downward motion. That is also where our point of inflection is located, when we change that shape of the curve. Okay, let's look at another example. Here we go. Whoops, it's jumping around on me today. So we're going to graph y equals negative 3 times the cube root of x minus 4 plus 5. So let's see. If I analyze where everything will move, well, this is my k. That should move my graph up 5 units. This being my h, and since that's positive, it's actually going to move my graph right 4 units. With this being a 3, that's going to stretch my graph vertically. And with this negative value in front, that negative value in front is going to reflect the x-axis. Okay, so we analyze all the features. I know that it has to move right first. So in order to get my function to move right 4 units, I'm going to start 4 units to the right. And I'm going to plot 4 in there. Now I know I got a lot going on in there. So I have negative 3 times the cube root of x minus 4 with that plus 5 outside. If I plug a 4 in there, that's going to make all of this 0, and my y value is going to be 5. I'm going to go 1 to the left and 1 to the right. So if I plug a 3, that gives me a negative 1 times negative 3 gives me a positive 9. Plus 5 is going to give me, let me do my math here again, negative 1 times negative 3 is going to be a positive 3 plus 5 is going to give me 8. All right, I'm going to go to 5. 5 minus 4 is 1 times the square root of negative 3 is negative 3 plus 5 will give me 2. And now I'm going to try to pick wisely here. I'm going to go all the way to negative 4. I'm pretty far away. But that gives me a negative 8 in there, and I know that the cube root of negative 8 is 2. Negative 2 times negative 3 is 6, plus 5 is 11. Again, you don't have to jump to that point. You can go just directly to point 2 if you'd like to. And again, I'm going to go the other direction. 12 minus 4 I know will give me an 8, so I'm trying to find perfect cubes in there. And that will give me 2 times negative 3 is negative 6 plus 5 is going to give me a negative 1. So I'll go ahead and plot these points. So again, this one that I found by moving it, 4, 5, is going to show me my point of inflection. Now that used to be my start with my square root function, but I can go in both directions here. Then we'll graph 5, 2. We'll graph 12. Oops, I went the wrong way. 5, 2. Give me a second here. Erase that off of there. 5, 2 is going to be here. My eraser's not seeming to work. Get those points out of there. There we go. 5, 2. And 12 is going to take me off my graph to negative 1. And when I go in the other direction, 3 is going to go all the way up to 8. And negative 4 over here is going to take me again off my graph to 11. So you can start to see that S curve as I follow those points in both directions. So our key components here, my point of inflection being at 4, 5. You can see that my domain, again, is going to be all real values. My range here is all real values. Now you can see that I did flip. That's why my graph looks a little different. So that means that my end behavior is going to look a little different. And my end behavior is going to go as we move to the left of my graph, my function this time is going to move up to positive infinity. As we move to the right of the graph, the function is going to move down to negative infinity. Okay, and that's how we graph our cube root functions. So in our last example, it's going to start with our cubic function and ask us to find the inverse and then graph them both on the same coordinate plane. So if I just simply start with the function itself, x cubed plus 2, and I really just kind of plug in some points there and make myself a table of values for that function. So if I cube 0 plus 2, that's going to give me a 2. If I cube 1 plus 2, that gives me 3. If I cube negative 1, that's going to give me negative 1 plus 2 gives me a positive 1. I'll go out to 2. 2 cubed is 8 plus 2 is 10. and negative 2 cubed is negative 8 plus 2 is negative 6. So if I graph that original function, 0, 2, 1, 3, 2 is going to go all the way up to 10, and then I'll go negative 1, positive, negative 1 is going to go to positive 1, and negative 2 is going to go down to negative 6. So here's my original cubic function. When I graph this, we're going to call this f. All right, now let's invert it. So I'm going to make this x equals y cubed plus 2. We'll subtract that 2 over, and then we're going to cube root. So y is going to be the cube root of x minus 2, or the inverse is the cube root of x minus 2. Now we could do this a couple ways. We could just start graphing like we've done the previous two, or I can go ahead and invert this graph and know that my graph of my inverse is going to flip these points. So instead of negative 6, I'm going to graph negative 6, negative 2, 1, negative 1, 2, 0, 3, 1, and 10, 2. So when I graph that, 3, 1, 1, negative 1, 10 is going to go up to 2, and negative 6 is going to be down to negative 2. I'm going to go ahead and trace those points. This being my inverse function, you should be able to draw that identity line and see the reflection from my original to my inverse. And that is how you graph your inverse functions of a cube to a cube root. So if you have any questions, please let me know. I hope you all have a great day.